Hey friends, when was the last time you could remember the rough details of something but not the exact name of it? This happens to quite a few people, so being able to search for something using semantics or meanings and going beyond just the exact text search is really important. This is where MongoDB Atlas Vector Search comes in useful. It allows you to store vector embeddings in your document stored in MongoDB Atlas and then use those to search against them. And what's great is because the embeddings themselves are stored in your document, you can store embeddings against both structured and unstructured data. So anything from text, video, images, audio, and more. I'm Luce Carter, Developer Advocate here at MongoDB, and in this video I'm going to take you through adding Atlas Vector Search to an existing application that uses the sample mflix dataset that you too can add to your cluster. By the end of it, you'll have a full application that is able to search the plot field for rough details of what you might be looking for and bring back any results that might match that. Useful, right? So let's get started. In order to follow along with this tutorial, you'll need a few things in place before we start. The .NET 8 SDK installed on your computer, an IDE or text editor that can support C# and Blazor for the most seamless development experience. This could be something like Visual Studio Code with a C# dev extension, JetBrains Rider, or another text editor of choice. An Atlas M0 cluster, which is our free forever tier, perfect for development. The connection string to your Atlas cluster, and then a local copy of two GitHub repos. The first is the Hugging Face dataset upload tool, and also you'll need a clone of the C# Movies GitHub repo. Links to both of these can be found in the video description. And lastly, you'll need an Open API account and a free API key. We'll be using the OpenAI API to create vector embeddings for our search terms, so you'll need a key and an account in order to carry this out. Once you've forked and then cloned the C# Movies repo, make sure to add your connection string into appsettings.development.json and appsettings.json in the placeholder section in order to connect your cluster. And if you don't want to follow along, the repo also has a branch called Vector Search, which has the full code implemented already. However, you will need to make sure that you have embedded data in your Atlas cluster for this to work. So the first thing we're going to need is some data stored in the cluster that has vector embeddings available as a field in your document. And what's really cool is that MongoDB has actually already provided a version of the movies collection from the sample mflix database called Embedded Movies, available here on Hugging Face, and it has 1,500 documents that uses a subset of the main movies collection, just to give you an idea of some embeddings. And the embeddings are done on the plot field, and they're available as a field called plot embeddings. So this is where the Hugging Face dataset uploader will come in useful. So this is a tool that I've written where you provide your connection string. It will go ahead and download this dataset here on Hugging Face and then upload it to your cluster using your connection string. So all you need to do is have it cloned locally on your machine, go to the root of the project and do .NET run. That will go ahead and start the application, and then once it's running, you will see it ask you for your connection string. So we're going to go ahead and enter our connection string here. This will then download our movies dataset. Once it's done downloading, it will then inform you that it's uploading the dataset. And then once that's done, we'll be able to exit and it will be available to us in our cluster. So just like that, we have it available for us to use. There are other options available for generating your own embedding should you want to, as well as Hugging Face is also OpenAI, Llama Index, LangChain, and others. I'll share a link in the video description for a tutorial that Prakul did for generative AI and other open source models if you want to go ahead and create your own embeddings. But for the sake of this tutorial, thanks to this tool, you will now have your embedded movies collection available in your cluster that will have plot embeddings available as a field. Now we have this embedded movies collection available in the sample mflix database. You'll see that the documents have this new field, plot embedding, which is an array of vector embeddings. We can now use this to create a search index, or specifically a vector search index. The reason for this is even though we have the vector embeddings available, we need to tell MongoDB that we want to carry out vector searches, and this is where to find those vector embeddings. So we're here in the Atlas UI, but you could also do this with if you want to use a UI tool. And you'll see along here a tab called Atlas Search. If we click that, it will bring up the search indexes. Now, if you don't have any indexes already on your cluster, then you'll see something like this. So we're going to go ahead and click the Create Search Index button. We then got some different options here. So Atlas Search is for text, full text search. We specifically want Atlas Vector Search. And at time of recording, we only have the JSON editor available, not a visual editor. But that's okay. We're going to make sure to select JSON editor under Atlas Vector Search and click next. And now you'll see here that it's automatically generated some JSON for us. So the first thing we want to do is specify where to find the vector embedding. So you may only have the sample data loaded in your database. You may in fact only have sample nflix and the embedded movies collection available. If you hadn't loaded the sample data set, which is quite all right, when the tool uploaded that data from Hugging Face, it will have created the sample nflix database for you and the embedded movies collection. So make sure to go and select it here. Then we can leave the index name as the default of vector_index for this tutorial. So now we're going to go in and add these details. So for path, this is the name of the field where we find the vector embedding. So as you saw from a few minutes ago or a few seconds ago, it is called plot embedding. Then we want the number of dimensions. So this is the number of dimensions that it was trained against. I'll share a link in the description if you want to learn a little bit more about what that means. But for now, we're just going to put 1536 in here. And then similarity is a type of function used to find similar results. And the options are there you go. You can either have Euclidean, which measures the distance, cosine, which based on angles, or dot product, which considers both. So for the sake of this demo, we're going to do dot product. So make sure that we write it outright with a capital P. There we go. So this now creates our vector search index through JSON, so we can click next. Wants us to quickly review it, but I'm happy with that, so click Create Search Index. What that'll do now then is go ahead and create this vector search index for you, and you will receive an email once it completes. So as soon as you get that email letting you know that your vector search index has been created, come back and we will start to make some changes to the back end of our code. Now we have our data with plot embeddings and we've created a vector search index. It's time to make the changes to the code. And we're going to start with the back-end functionality and then work our way forwards. So we're going to start off by adding our OpenAI API key to settings. And what we're going to do is we're going to go into appsettings.json and then later appsettings.development.json. So at this point, you should have already updated the MongoDB settings with your own Atlas URI, but under that, we're going to add a new value, which is going to be open API key. And then in here, inside a string, this is where you would put the OpenAPI API key that you created before you started. So go ahead and do that. Once that's done, we will then open program.cs where we will start to use it. So up here where we've created the build, we now want to get an additional value from the configuration, which is going to be that OpenAPI key. So we're going to create OpenAPI key. And that's going to be builder, a bit like below dot get, but get value. But rather than get section, we're going to do get value, and it's going to be of type string, and it's going to be called open API key. Nice and simple. The other thing we're going to do here, which will error at first, that we will fix later, is here where we create the MongoDB service. We're going to update it later to take in this open API key. So we're going to pass it the open API key. Obviously, we haven't updated the methods, the constructor signature yet, so that will error, but that will get fixed later. So now we've done that, we can save file, and it's time to go into the implementation. So the way this works is for any of the code that talks to the MongoDB database is a method with the implemented interface, not a method, a class. So the first thing we're going to do is we're going to add a new method to the iMongoDB service, which will be the method that we use to carry out our search. This is going to be a public, and it's going to be an IEnumerable because we'll get back a iterable list of films that match the criteria. So we're going to do movie search here, and that will take a string of what we want to search for. Text to search. Right, so now we can go in and ask our MongoDB service to implement that missing method from the interface. So we're going to add a couple of using statements at the top first that are going to come in useful later on. So we're going to add system.text and system.text.json. And you'll see later on why these are useful. We're also going to add a couple of new private properties here. So the first one is going to be a local version of our Open API key. And then we're also going to do a HTTP client. We're actually going to new that up straight away because we can. We don't even need to do that. We can just do that. There we go. So as I mentioned and you saw before, we're going to update the signature here. So this is going to take the string of the Open API key. So we're just going to update this to say that the Open API key is equal to Open API key. Nice. The other thing here that to note is that the current application uses the movies database to pull in all the films. We need to make sure that we update this to be the new collection embedded movies. Otherwise, it will never find any results because there isn't that plot embedding field to search against. So we've done that and now it's so simple. So that is our service sorted out. Now the next thing we need to do is we need to update the movie model. The reason for this is because the movie documents that are part of the embedded movies collection on Hugging Face have a slightly different shape, so fields and data types, to the current model. So what I'm going to do is I'm going to go ahead and copy and paste the contents of this, but this will be available to you in a gist in the video description, so you'll be able to copy and paste the same. So we're going to replace the contents of the whole thing. So a lot of these will look similar, but some of it is just that it uses slightly different data shape. So now we've got all the things that we need, including this new plot embeddings field at the bottom. And you'll see this use here of this beacon element attribute. If you're fairly new to MongoDB, this is just saying that we want to map this property to this specific field, so that if you've got, as you can see here, this is using is it what they call is it kebab case, I think? No, that's snake case maybe. Anyway, the point is that this is obviously spelt differently. It's got an underscore, there's different capitalization, whereas this is following C# naming conventions where you normally, if nothing else, start with a capital letter. So this attribute is just part of the MongoDB driver that just allows you to map between how you want to call your C# properties and the fields in the document. And then it will take care of mapping between them for you because the driver is smart like that. Okay. So we've added the ability to search and we've changed the model. But before we can start implementing it, one of the things we need to do is handle the response it will get back from the OpenAI API. Because when we add search to the front end, one of the things that will happen is that the user will type in a search in the box and then it will do the search. But obviously the way a vector search works is it's doing comparisons, in this case using dot product, across the vector embedding. So that means that what we are searching for also needs to become a vector embedding so that the comparisons can be made. And that is where the OpenAI API comes in. So we're going to make a call to it with the HTTP client, but one of the things we're going to get back is a response and we need to map that. So what we're going to do is we're going to create a new class in models and we're going to call it embedding response. And that is what we're going to turn to convert our responses to so that we can then access properties on it that we want for our search later on. So we're going to create a class and we're going to call it embedding response. Again, I'm going to copy and paste some code, but as I say, it'll all be in the gist available in the video description. So we're going to replace the current empty class with this here. So it's just some fields. This isn't going to become a MongoDB document, so it doesn't have any of the driver attributes. And if you've not seen it before, this is like an escape character. So because object is a data type in C#, we just put an @ in front of it and it will then ignore it because there is a property in the embedding response called object. So we can save that. And now we can add a method to request the embeddings for the search term. And this is where we're going to make use of that API key that we've passed in. So this is going to be inside of MongoDB service. So we're just going to close the other tabs just to clean things up a bit. I will go ahead and add my Open API key here so that we can run it later, but you won't see me do that because, of course, I don't want to reveal too much, but I'll leave that open in the background for now. So here we are in MongoDB service, and we are going to add some code that will be available in the gist, and this is going to be a private method, so we'll pop it down at the bottom. So this, put it in the wrong place. All right, we just need to put an underscore on top of that, keep the naming consistent. So what this get embedding some text method does, it takes in the string that we're searching for, creates a dictionary. So when you call the Open API, it expects you to pass it this object that contains the model you want to use and the input. So in our case, we're using the text embedding ADA002 model, and then we are passing in that text as our input. Then we set up, some basic HTTP client stuff, the authorization with our API key. Then we make the request to the embeddings endpoint, and if it's successful, then we read the response, convert it to that embedding response, and then return the embeddings from the first object in the data response. So this is just part of what you get back from the API. So you just have to specify that it's the first one and get the embeddings back. And that will give us the vector embeddings for the search term. So now we've got that, we can actually start using it, because as we said before, we need to compare it. So here, we just need to do to string here, because as I mentioned earlier, the data types has changed slightly between the models. So we just needed to update the existing code here, get movie by ID, but now we're going to implement this movie search. So we're going to, again, copy and paste some quick code, and then I'll talk through it. So this creates a vector by calling that method we just wrote, and then converting that vector result into an array. We create some vector options. So we specified the index name. So that's that vector underscore index default value. If for whatever reason you chose to update from the default index name when we created the index earlier, just make sure to update that here. Then number of candidates just specifies number of results you want to get back, so you can limit it if you choose. And then we build up an aggregation. So vector search is part of the aggregation pipeline, and in the C# driver, we can obviously carry it out all in one line, which is quite neat. This is just broken up for neatness. But we're saying call aggregate, and then as part of that, we want to run the vector search pipeline. The field that we want to run the vector search against is the plot embedding. We're passing it in that vector, so we're comparing the plot embeddings with the vector. So we're saying take this vector and search in the plot embeddings, limit it to 150 results, and then take in our vector options. We're then saying get back the we want to get back a movie type, and we want to include the title, the plot, and the poster. The reason for the poster is because in the UI, as you'll see later, each movie card has a picture, and we use the URL of the poster to display the image. Convert it to a list and return it back. Nice. So the back end is now complete, and we can move on to the front end. So the front end functionality is going to be split into two parts. The code in the front end for talking to the back end, and then the search bar in the HTML just for, entering your search term. So we're going to start off by handling the code for search. So in our components and our pages, we're going to go into home.razor, and you'll see that there is some existing code here already because this is a working application. And in the code block, we've got some variables and some code for pagination and getting all the movies. The first thing we're going to do is we're going to add a new string for search term, because this is what we're going to bind the HTML to later. Then we're going to implement a new function here, which is going to be private void search movies. Because we have the search term up here as a variable, we don't need to pass it in as a parameter. So the first thing we're going to do is we're going to say if string.is null or empty. There we go. The search term. So essentially, if the search box has nothing in it, just make sure that you get the all the movies. Because what we want to happen is that if the box is empty, we want to show everything. Otherwise, we will then do our search. So movies now is going to be the MongoDB service, but this time we're going to do movie search, and we'll pass it search term. So that part's pretty straightforward. And just like that, we have the ability to search. So the next bit we're going to do is add the search bar. So at the top here, we have a header, and we have it's a clickable name of the project here. So beneath that, we're going to add some new code. So we're going to add a div in here, which will also be in the gist. So this div is just using Bootstrap, which comes out of the box of Blazor, and it's just a form. It's going to have a class on it called search bar that we'll add into the CSS shortly. But it takes an input, which is a form control. It's a search box, and it's placeholder text, ARIA label for accessibility because that's important, and then bind it to that search term variable below. Then just have a button next to it that says when you click it, carry out that search movies method. Pretty straightforward. Now, if we ran this now, it would work, but it wouldn't be very pretty. The search bar would be in a strange place in the header, and as you saw, we've already specified that search bar class. So before we run it and test the application, we're just very quickly going to make a change to the CSS to make it look better. So inside of www.root, we have app.css. All we're going to do is add a couple of class things in here. We'll do it after top bar. So we're just adding some padding to the button and the search bar itself. Just give it a bit of padding to move it around and give it some space. So excellent. And just like that, we can test it. Great. So we have our front end and back end functionality implemented. Now we can actually run it and see our new search in action. So we'll go ahead and click run at the top and wait for it to load, where we will hopefully see our new search box in the header that we can interact with. Nice. So we have the search box here and we can go ahead and carry out a search. So maybe we can search for 3 young men and a sword, which, if you don't know, I'm thinking of Three Musketeers because I quite like that film, book and TV series. And there we go. It's come back with our search results. Nice. What you'll notice as well is because it's doing a vector search is that it's come back with Three Musketeers, which is what I was thinking of, but it also comes back with any other films that it thinks might be close to what it is I was searching for. So anything that might involve 3 young men or swords. All pretty clever, right? There you go. In just a few minutes, you've been able to add MongoDB Atlas vector search capabilities to a Blazor application built upon the sample mflix collection. You've been able to add OpenAI API capabilities to make your vector embeddings against the text, and then use those to search against the plot field. Of course, as I mentioned at the beginning, Atlas vector search searches so much more than just text search. So what will you search against today? As ever, all links that you might find useful can be found in the video description, as well as our community forums where you can ask lots of questions, where lots of knowledgeable people will be able to answer them for you. Happy searching!